We are going to take notes on factoring trinomials. And these trinomials are the kind that have a equal to 1. I'll explain that in a minute. Please copy down your essential question. How do we factor trinomials with a equal to 1? And what is a perfect square trinomial and how do we factor it? We are going to look at today factoring trinomials when a equals to 1. We are not solving trinomials, that comes later. This is an expression because it does not have an equal sign. So we are going to look at factoring trinomials of this form when a equals to 1. But before we can factor anything else, we factor out the GCF first, greatest common factor. And so that is exactly what our steps say. The first thing that we do is a GCF. We find two numbers that multiply to equal to a times the c and add to equal to b. This will be easier to understand when we have an example in just a second. We write two binomials. The answer is going to have this form. And here's some hints that you will want to come back to later. So pause your camera and get this part copied down in your notes. When you have that copied down, come back for example number 1. So here is example number 1. ax squared plus 4x minus 12. A is the number in front of the x squared. There's not a number in front of the x squared, so the a is equal to 1. B is the number in front of the x. C is negative 12. What do I get when I multiply a times c? Well, that would be negative 12. So I'm going to make a little note over here. I need to know what the factors of negative 12 are. Factors means the numbers that multiply together to get negative 12. And so 1 times 12 would equal to 12. I'll come back to the signs in a minute. 2 times 6 would equal to 12. 3 times 4 would equal to 12. Those are the factors of 12. If this is going to be a negative 12, then one of these two numbers in each pair is going to have to be a negative. What it says up there in the top, in order to factor this, I need a number that multiplies to get 12 and adds to get a positive 4. Since this is a positive number out of my pair, since this is a positive number in the pair, the biggest one needs to be positive. So if I multiply negative 1 times 12, it's equal to negative 12. If I multiply negative 2 times 6, it's equal to negative 12. If I multiply negative 3 times 4, it's equal to negative 12. But do any of those pairs of numbers add up to equal to 4? That pair of numbers would add up to equal to 4. And that's the pair I'm going to use to factor 1x squared plus 4x minus 12. X minus 2, x plus 6 is the factored form of this trinomial. What does it mean it's the factored form? That means that if I multiplied it together, it would equal to the one that I started with. As you know, I prefer to use a box problem to do my multiplication, combine like terms. That's what we started with. What I am doing is undoing the box problem that I learned a few days ago. So this is the factored form of this trinomial. This is the binomial times the binomial that if I multiplied it together, I would get this trinomial. That's what I'm trying to accomplish. The reason I'm trying to accomplish it is then the next step will be to solve this, and that's going to help me solve the equation. So, what I am looking for is the two binomials that when I multiply it together, it's equal to that trinomial. In order to do that, I identify the A and the B and the C. The A is equal to 1. That's the kind of problem we're focusing on today. The B is -9 and the C is 20. If I multiply the A and the C together, I get positive 20. I'm going to need the factors of 20. The factors of 20 are 1 times 20 and 2 times 10, and not 3, but 4 times 5, and those are all of the factors of 20. Now, 20 is positive, but this number right here is negative. And that's how my little chart up here that I made is going to help me. If I have a negative sign for the B and a positive sign for the C, both of my factor numbers have to be negative. I need a -1 times a -20 to add up to a positive 20. I need some negatives in here because I'm going to need them to add up to equal -9. Could any of my pairs of numbers add up to equal a -9? Those are my factors. X minus 4, X minus 5. When I multiplied it together with a box problem, it would be equal to that. Let's check it out just to make sure. This is a check. You do not have to do that on every single problem. I am doing it on these problems to show you that it ties together with what we were working on last week. So if I combine like terms, that's what I get. That's the problem that I started with. When I look at this problem, it looks like the A is equal to 1, and the B is equal to 4, and the C is equal to -3. But I haven't done step 1. Step 1 says factor out the GCF first. Is there a number that divides 2 and 4 and -30? And that number would be 2. This 2 that I factor does not get thrown away. It factors out in front. And 2 divided by 2 would be 1. 4 divided by 2 would be 2. 30 divided by 2 would be 15. So when I get finished with my answer, that's what the answer is going to look at. The 2 stays out in front. I don't lose it. And so in order to fill in my factors, I need to identify the A, the B, and the C. I need to multiply the A times the C together, and I will get -15. I need the factors of 15. And you do not have to write down a factor chart like this. I do it every time, so don't miss a factor. And it helps some of you that have forgotten some of your multiplication factors. 2 doesn't go into 15. 3 will go into 15. 4 doesn't go into 15. That is all of the factors of 15. Now, I need a pair that's going to add together to get a +2. If it's a negative 15, I got to have some negative numbers in here. If this is positive, the bigger number has to be positive. So my negatives need to go like that. This pair will add up to equal this positive 2. This pair will multiply together to get negative 15. This pair is my answer, x minus 3, x plus 15. If I multiplied this all out with a box problem, it would be equal to the problem that I started with. You always start by looking for the GCF. This doesn't have a GCF, and the A is equal to 1, the B is equal to negative 18, and the C is equal to 72. I need to multiply my A and my C together, and I will get a positive 72. Since this number is positive and this number is negative, I am going to need a positive negative over here in my factor chart. So 1 times 72 and 2 and 36. 3 goes into 72 24 times. 4 goes into 72 18 times. 5 doesn't go into it. 6 goes into this 12 times. And 8 times 9 is equal to 72. If this is negative, the bigger number has to be negative. And if this is positive, and so they have to be the same. So now I need to look and see if I can find a pair that is going to add up to equal negative 18. So my factored pair would be x minus 6, x minus 12. That is the factored form of the trinomial that I started with. If I multiplied that together using FOIL or a box problem, it would be equal to the one I started with. Now, once again, this is one step in solving. So we're going to learn how to do this, and then we're going to learn how to take this and solve an equation. Now, this one does not start out with an x squared. It's x to the 4th power, but it still has the same form, and so we still can use the same process. The A is going to be equal to 1, the B is going to be equal to negative 5, and the C is going to be equal to negative 24. When you multiply A times C, you get negative 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. If this is negative, the bigger number has to be negative. If this is negative, they have to be different. So could any of these pairs add up to equal negative 5? Now the only thing that's different about this one is x squared times x squared equals x to the 4th power. This one looks a little bit different, but it still has the same pattern. You look for a GCF first. It doesn't have one. So A is equal to 1, B is equal to 3, and C is equal to negative 28. So A times C, First number times the last number is negative 28. The factors of 28 are 1 and 28, 2 times 14, 4 times 7. Since this is positive, the bigger number has to be positive, and since this is negative, I've got to have a negative in there somewhere. Is there a pair of numbers that can add up to equal 3? There it is. That's going to be my numbers. So x and x will give me x squared. But what about the y? So y times y would give you y squared. And when you multiply the box problem together, the middle terms, maybe I should go ahead and show you. Let's check this out using a box problem. X times x is x squared. When I multiply those two together, I get 4xy. When I multiply those two together, I get 7xy. And 4 times 7 would be negative 28. Y times y would be y squared. Combine like terms. When you combine those, you get 3xy minus 28y squared. Again, this part right here is a check, and it doesn't need to be completed on every problem. You just might want to complete it on something you're not sure about. Now, I have difficulty factoring if this is not a positive one. So if this is a negative one, the first thing I want to do is factor a negative one out of everything. So my answer is going to be in this form. When I factor a negative 1 out, x squared minus 5x plus 6. So my a times c would be 1 times 6, and the factors of 6 are 1 times 6 and 2 times 3. The 6 is positive, and the b is negative. If the b is negative, the bigger number has to be negative. If this is positive, they have to be the same. So this is the pair that I need. So this is going to be x minus 2, x minus 3. That is the factored form.